This video is going to cover section 4.7, which is titled How to Experiment Well. In the previous lesson, they talked about the 4 components to a well-designed experiment, and that is comparison, which is where they spent most of that lesson talking about, control, random assignment, and replication. So this lesson focused on the random assignment portion. It was pretty short in terms of content. They just gave a lot of examples. Which is what this will look like too. So remember that random assignment is when experimental units are assigned treatments using a chance process. So we're assigning them to their treatment using a chance process. The key thing here, and the reason that random assignment is important, is because it creates roughly equivalent groups in terms of variation of those experimental units. So it's taking all the differences that the experimental units have and spreading them across groups by randomizing, or at least that's the hope of random assignment. Randomization is a method where participants or items are selected with the chance process. And again, this increases the chances of getting a sample representative of the population. So the idea is that I take all those variations of the experimental units that I want to put in my sample, and I get ones with each of the characteristics that are in the population, so that my sample is a mini population. That's always the goal, that your sample is a mini population. So an example of this would be assigning numbers to members of the population and then either drawing those numbers, or if there's a lot of them, using a table of random digits to assign the groups. Something that is not randomization is just like, so if I need groups of 10, I'm not going to take the first 10 experimental units and say, okay, this is my treatment group, and then I'm going to take the next 10 and this is my control group, right? I can't do that. That's not randomizing. So in these examples, they used a 3-step randomization process. The first step is to label. So ultimately that means I'm going to assign numbers to the experimental units. Then I'm going to randomize. By randomizing, I'm either drawing the numbers or I am using a random digits to do this. Then I select, it's going back to the labeling part, right? It's kind of combining the two. Is look, ultimately I'm looking at the labels. And identify my groups. Based on however many I'm looking for, right? So if I'm looking for the first 20, that's my control group, or something like that, then I'm going back and selecting that way. So in these first 2 examples, we're going to look at what component is missing. So one of those 3 things is not done in this situation, and we're going to identify it. So a researcher is interested in whether using mental imagery can help people remember specific details when given information. To conduct the experiment, a researcher asks 100 volunteers to participate. The first 50 people that arrive are put in the treatment group, while the rest are put in the control group. The volunteers' names are written on slips of paper and placed in a hat. The researcher randomly selects a name to determine whose turn it is to participate. So remember that the process of randomizing is putting them into the groups, not whose turn it is to participate. Okay, so when it's talking about the first 50 people are put in the treatment group and the rest are put in the control group, that's not randomizing. Okay, so that means that step 2, so the researcher didn't randomize or use a random process to select the groups. or treatments. Okay, so it was missing that step 2. In the next example, we have a researcher is interested in whether using mental imagery can help people remember specific details with given information. So same situation. To conduct the experiment, a researcher selects the treatment group by placing numbered slips of paper in a hat and randomly selecting half of the numbers, making sure to mix the slips in between each selection. Which component is missing from the researcher's process? So if we think about where that sentence started, it actually started with step 2, right? We started here. And so that means that this researcher didn't label the experimental units or the people being studied. So they missed step 1. They didn't label the subjects with the numbers, right? So they had to label the subjects with the numbers before selecting the numbers. Okay, so next example, an education researcher is interested in comparing the learning outcomes of students who are taught a lesson using 5 different teaching techniques. There are 75 students in the school who can participate in the experiment. Using a table of random digits, the researcher will randomly place the students into 5 equally sized treatment groups suitable for comparison. How many unique random numbers must be read from the table of random digits? So they're doing 5 equally sized treatment groups. So one thing we want to start with is there's 75 students that can participate. We want to divide that number by 5 so we know how many people are in each treatment group. So that means there's 15 in each group. When I'm drawing the names, I actually only have to draw for 4 groups. The reason being is that once I've got my fourth group drawn, I only have 15 names yet left. I don't have to draw those numbers or select those numbers to tell who's in that group. It's whoever's left, right? And so to figure out how many numbers must be read from the table, I'm gonna take 15 and I'm gonna multiply it by 4, which is 60. Okay, so I need to read 60 names in order to create 5 equally sized treatment groups. Okay, so I'm always going to select one less group than I have to save myself some time. I don't need to draw the random numbers for that because those people are just whoever's left over. In this last one, we're going to go through a whole process of looking at selecting groups again. So using our table of random digits. So in aeronautical, researchers have developed 3 different processes to pack a parachute. They want to compare the different processes in terms of time to deploy and reliability. There are 5,100 objects they can drop with a parachute from a plane. Using a table of random digits, the researchers will randomly place the items into 3 equally sized treatment groups suitable for comparison. Carry out the random assignment using the given selection from a table of random digits, starting from the first row in the first column. So the first question here is, what would be appropriate labels for the objects? So if I have 5,100 objects, remember that there's essentially 2 ways we can do this. So one way is we start at 0, 0, 0, 0, and we end at 1 less than what we have. So it would be from 0, 0, 0, 0 to 5,099. So 1 less than what we have. Or we can start at 0, 0, 0, 1 and stop at 5,100. Okay, so one of those 2 is the only way that we can number these. So that you will have questions where it asks you just that labeling. So this is review from before. So is this next step. So then they want us to just pick the first 5 items to process group 1. So I'm going to use these numbers to do this. So if I have 0001 to 5,100, I'm looking for a 4-digit number that's within that range, and those are going to be selected for the groups. So if I look at this, my first 4-digit number is 6,011. That's bigger than 5,100, so that's not going to be chosen. My next 4-digit number is 8,572, also too big. Then I've got 719. That is less than 5,100. Oops, that is in my range. Okay, so that one's gonna work. Next one, 5769, too big. 2825, that one works. 2825. Next one is 3031, that one works. So I need 5 of these. I've got my first 3, so I want 2 more. 2628 is the next 4. 2628, so that one's within my range. And then the last one, 2719, works. And so that is the last of the first 5 that they were asking for. So the first 5 items to process group 1 would be 2,719, 2,825, 3,031, 2,628, and 2,719. Wait, I found a problem. That's a repeat. So that one is not a member of our group. Let's see if the next one is. So 3,562, looks like we don't have that. 3,562. So that one is our 5th one, 3,562. Okay, so remember that this was focusing on randomization, knowing that we have these 3 steps in the randomization process. We have to label them with numbers, then randomize them, and then select them into their treatments in order to have a well-designed experiment.